Telescopes on Earth have greatly enhanced our ability to observe the stars by collecting more light than our eyes can see. President Biden recently introduced the first public image from the James Webb Space Telescope, which represents a significant advancement in space research. The James Webb Space Telescope stands head and shoulders above the competition due to its groundbreaking design and capabilities. It is exploring the mysteries of our solar system, other planets orbiting distant stars, and our place in the universe. A star located 120 light-years away from Earth was the target of a recent experiment using the Webb telescope. Astronomers are still puzzled by the potential presence of carbon-based molecules in the atmosphere of a planet believed to be covered in water, following the telescope's findings. This discovery opens exciting new possibilities for potentially habitable worlds in the cosmos and provides a fascinating look at a planet that is entirely different from anything in our solar system. Here you are in Lab 360. Let the adventure begin. If you want to stay up to date on all the space news, be sure to subscribe. The exoplanet K2-18b, which has 8.6 times the mass of Earth, has been studied by NASA's James Webb Space Telescope. Carbon-bearing substances, including methane and carbon dioxide, have been discovered on this planet. Previous studies support these findings, suggesting that K2-18b may be a high-sea exoplanet, meaning its surface is covered by water and its atmosphere is rich in hydrogen. Our understanding of this system has transformed since initial observations with NASA's Hubble Space Telescope revealed atmospheric features of this habitable zone exoplanet, located 120 light-years away from Earth in the constellation Leo. K2-18b orbits a cold dwarf star with no similar surrounding planets. Exoplanets like K2-18b, whose diameters fall between those of Earth and Neptune, are unique in our solar system. Astronomers are divided on the characteristics of these sub-Neptunes due to the limited knowledge about their atmospheres. Some scientists believe that exoplanets in the high sea region provide ideal conditions for searching for signs of life, making the possibility of K2-18b being one of these worlds intriguing. The lack of ammonia, combined with the abundance of carbon dioxide and methane, supports the theory that K2-18b has an ocean of water beneath its hydrogen-rich atmosphere. Dimethyl sulfide, a molecule that can only be produced by living organisms on Earth, has been detected in initial results from the Webb Space Telescope, raising the prospect of its detection on K2-18b. On Earth, plant life in the ocean is responsible for releasing most of the dimethyl sulfide that enters the atmosphere. However, the inference of dimethyl sulfide on K2-18b is weaker and requires further validation. According to a University of Cambridge scientist, future investigations by Webb should be able to confirm the presence of dimethyl sulfide in detectable amounts in K2-18b's atmosphere. Even though K2-18b contains carbon-bearing molecules and lies within the habitable zone, that doesn't guarantee the planet can support life. K2-18b has a radius 2.6 times that of Earth and is believed to possess a massive core under high pressure like Neptune, but with a thinner hydrogen-rich atmosphere and an ocean surface. For high-sea worlds, vast bodies of water are expected. However, it is also possible that the water is too hot to sustain life or even remain in a liquid state. We have obtained the most detailed spectrum of a habitable zone sub-Neptune to date, which has enabled us to identify the molecules present in its atmosphere. Subhajit Sarkar of Cardiff University commented that the research into the propagation of light from K2-18b's parent star through the exoplanet's atmosphere allowed for this examination. K2-18b's luminosity dims as it transits its home star, and in 2015, NASA's K2 mission utilized this method to discover the exoplanet. During transits, a tiny fraction of the sun's rays pass through K2-18b's atmosphere and eventually reach space observatories like Webb. As light travels through the atmosphere of an exoplanet, it leaves traces that scientists can analyze to determine the composition of atmospheric gases. The research team plans to conduct further studies using the mid-infrared instrument spectrograph of the telescope, with hopes that these studies will confirm their findings and provide new information about K2-18b's climate. The discovery of life on a habitable exoplanet would revolutionize our understanding of our role in the cosmos. According to Madhu Sudan, water has also been detected by the Webb telescope in other locations. Complex chemical compounds resembling smoke or haze were found in a distant galaxy by astronomers using the James Webb Space Telescope. We have pushed back the previous record for such detections by nearly an additional billion years, marking the oldest known example of complex organic molecules identified by humans. The fact that these findings at the cosmos periphery are shaking up our understanding of cosmology is, in my opinion, and perhaps yours as well, both exciting and terrifying. This groundbreaking finding reveals that an early galaxy, originating around 10% of the universe's current age, contains these complex molecules. Polycyclic aromatic hydrocarbons, carbon-based compounds found in smog, coal deposits, and oil on Earth, have also been detected. Lead astronomer Justin Spilker emphasizes the significance of this discovery, noting that the molecules found are not simple substances like water or carbon dioxide. They are huge, complex molecules containing hundreds or even thousands of atoms. Interestingly, while our models suggest that the cosmos shouldn't have been able to produce such large and complicated molecules so soon after the Big Bang, the fact that it did is astounding. With the universe being approximately 13.8 billion years old, the light scientists can detect started its journey just over 1.5 billion years after the Big Bang. We are witnessing the primordial era of the universe's development. Thanks to Webb, we've pushed back the previous record for such detections by roughly an additional billion years, allowing us to identify these complex organic molecules. What if, instead of only looking at the Big Bang, we could go much further back in time? Would we discover more of these molecules? If so, our cosmological models and scientific knowledge would be profoundly impacted. Additionally, earlier attempts to identify complex organic molecules in distant galaxies could only confirm the presence of these chemicals. Thanks to Webb's sensitivity, we can now discern finer details about the precise location of these molecules within a galaxy. We still do not know why the concentration of these chemicals is not uniform in SPT 0418-47, an early galaxy. Furthermore, this finding provides additional evidence that galaxies were forming throughout the early cosmos when a lot was believed to still be happening. Fascinatingly, despite being only a tenth as old as our Milky Way, this galaxy was already as large and had produced as much carbon and oxygen as our own. The vastness and intricacy of the universe continually astound us as we, as a species, venture forth into the unknown, equipped with knowledge, curiosity, and a relentless quest for understanding. From the tiniest subatomic particles to the largest galaxies, the cosmos presents an awe-inspiring tapestry of phenomena that challenges our comprehension and inspires our imagination. With each new discovery, we are not only uncovering the mysteries of the stars but also redefining our place within the universe. The advancements made by the James Webb Space Telescope represent a monumental leap forward in our ability to observe and interpret the cosmos. As we analyze its breathtaking images and data, we find ourselves on the brink of monumental revelations about the nature of exoplanets, the formation of galaxies, and the potential for life beyond Earth. Every breakthrough in our understanding brings us closer to answering profound questions that have intrigued humanity for centuries. Are we alone in the universe? What is the origin of life? How do galaxies evolve over time? As we peel back the layers of cosmic history, a fresh light on the cosmos emerges, illuminating the pathways of discovery that lie ahead. These explorations are not merely scientific pursuits, they are part of a larger narrative that connects us all. Each finding has the potential to inspire future generations of scientists, engineers, and dreamers. It reminds us that our shared journey through the universe is just beginning. If you found this video interesting, we encourage you to click the like button and leave a comment with your thoughts and questions. Let's embark on this journey together, exploring the universe one discovery at a time. Be sure to subscribe to Astro Lumine and hit that notification bell so you never miss an update on our cosmic adventures. Your participation in this exploration is invaluable as we collectively seek to understand the wonders that lie beyond our home planet.